Hi friends, this is a video which explains about the assignments that we have in the Applied AI course with more details on why we have these assignments and what all types of assignments we have and how hard or easy some of these assignments are, right? And what is the rationale and reasoning behind having the assignments in the very first place. So first and foremost, let's ask a very simple question. Why do we have assignments in the course? The fundamental reasoning is because we want you to learn practical and real world skills which are required for careers in data science, machine learning and AI. If you just know the theoretical concepts, you will not be able to survive in the real world as a data scientist or a machine learning engineer or in any AI role. You need practical and real world problem solving skills. While in the course videos, we explain a lot of theory and provide the intuition behind the theory using geometry, using analogies and intuition, also using a lot of mathematics. We try to cover the theory in full depth and glory. But at the same time, in the course videos, we also have code walkthroughs. And the whole purpose of assignments is primarily to translate some of the mathematics, some of the geometry, some of the code walkthroughs that we have seen in the course videos to practical knowledge. It is to translate theory and what you have learned in the course videos, both theory and code walkthroughs that we have covered in the course videos, right? So all of them into some practical exposure. Again, from our own experience of helping many students crack job interviews in data science and machine learning, we believe that these assignments have played one of the most critical and most important roles for our students to crack jobs. Right? They are literally at the very core of any job interview or any ability to crack job interview. So let's go step by step. So what resources do we provide for you so that you can solve these assignments comfortably? First and foremost, in the course videos. So if you go through the course videos, within the course videos itself, we provide a detailed explanation of all the concepts, both mathematically, geometrically, intuitively, etc. Then we have a lot of code walkthroughs and also explanation of APIs, of various functions, classes, and libraries. Again, these code walkthroughs can be seen both in the course videos, also in the live sessions that we have conducted. Again, these live sessions are pure code walkthrough live sessions. So we have conducted over 25 plus just code walkthrough live sessions, and we have added all of these live sessions to the course videos at the end of respective modules, right? So in addition to explaining the concepts very intuitively and diagrammatically and mathematically, we also have a lot of code walkthroughs and explanation of APIs as part of the regular course videos and also as part of code walkthrough special live sessions that we have conducted. And all these live sessions, we have added it to the course videos to further help our students solve these assignments better. Next, for every assignment, you will encounter a bunch of assignment videos. Let me show you an example. So here is one of the assignments that we have as part of our course videos. In this assignment, we implement backpropagation on a very simple example, and we also perform gradient checking. These are concepts that we explain as part of our deep learning part of our course videos, right? In the deep learning modules. Now, the first sample video that you'll see here is how to work with Google Colab. Again, we recommend all of our students to use Google Colab because some of our students may not have the computational resources on their respective laptops like GPUs, right? So here is a short video where we explain about how Google Colab itself works, how to get started with Google Colab. Again, these are part of your assignments. Again, all of our assignments can be accessed through classroom.appliedaicourse.com. When you join our course, you will be able to access our classroom via classroom.appliedaicourse.com. This is one of the assignments. So for this assignment, we first want you to watch. If you don't know how Google Colab works, our team has done a detailed video on how to use Google Colab and how to actually use it effectively. The second thing that we do is we also explain how to solve this assignment. What is the assignment itself, right? We have a detailed video here where we show you some code snippets on how to load data, what is a computational graph, right? We explain all of these concepts here in this video. So this video is specifically meant for this assignment only, where we explain what is the problem, how to solve the problem step by step. We give a lot of details here. In addition to this, in addition to these two videos, And we call these as assignment videos because these videos are designed specifically to help you solve this specific assignment. In addition to that, we also provide you a Google Colab link or a IPython notebook which you can download to get started with. We not only give you videos to solve the assignment, we also give you sample code so that you don't have to write the code from scratch. For example, if you open this Google Drive link, you'll get an IPython notebook which you can open on Google Colab. So on this Google Colab, you'll see what the problem definition is, how to load the data. Again, there are diagrams which explain each part of what you have to do clearly. There are also additional videos that are given sometimes. Again, you don't have to watch all these videos, but these are primarily to help students get more resources than what we've already provided. Again, the whole backpropagation we explain in lots of detail. We almost spend 2 hours in our course videos explaining backprop in detail, step by step, line by line. But if you want more resources, here are more resources for you. Then we also tell you how to debug your code, how to break the problem into subparts. And we give you some basic functions and we ask you to implement it here. Just look at this. We say implement this function called forward propagation. What should X be? What should Y be? What should W be? What are all these things? So we give a lot of detailed explanation in the IPython notebooks and Google Colab notebooks on how to implement it itself. Again, we talk about gradient clipping, which we explain anyway in the course videos, but we also give you more details here. Okay, we give you some worked out examples so that you can debug your code. Again, we tell you how to implement this gradient checking. Again, more additional videos, more contents. Again, all these resources are given to you so that you can easily complete the assignment. So for an assignment, in addition to providing a bunch of videos, which we have created, we provide you starter code in IPython notebooks. We give you a detailed explanation on what each function should implement with more additional resources, both external and internal, on how to tackle these assignments. So we are providing enormous amounts of resources for you to solve any assignment. Again, this is just one of the many assignments that we have. So as we have just seen, we give you a lot of assignment videos, sample notebooks. In each notebook, we also give you functions to implement and what the function input should be, what the function output should be. You just have to write the logic within the function. And we give you a lot of additional instructions and external resources also to help you. In addition to all of this, we have a dedicated team of mentors who, if you are stuck, will give you additional hints. If you want more external resources, because probably you're stuck at a specific concept, they'll provide you more external resources and references. And if you're stuck anywhere and if you have a doubt, they'll also clarify your doubt. But please understand that our mentors will not give you solutions, because the objective of assignments is for you to solve these by constructively trying to build a solution. We provide lots of hints, we provide lots of other references, we clarify as many questions as we ask, but we do not give you solutions, because that way you will not be learning the skills that are actually needed in the industry for data science and machine learning jobs. We want you to solve these assignments with our help, with all the resources that we are providing now. Okay, so there are 4 types of assignments broadly. If you take all of our assignments, the 30 assignments that we have, broadly they fall in 4 categories. The first category is a programming category. This is where we have a bunch of assignments on Python and on SQL. Again, the second one is a type of assignments where we implement a machine learning concept or a deep learning concept, like the backpropagation algorithm that we just saw a while ago. That's one of the assignments where we explain a concept called backpropagation, which is central to whole deep learning. The third type of assignments that we have are basically assignments where we solve a real world problem, not by implementing everything from scratch, but by using popular libraries like scikit-learn, like XGBoost, like TensorFlow, like Keras, etc. The fourth type of assignments that we have are self-case studies and the corresponding blogs that you have to write for the case studies that you complete. So there are broadly 4 types of assignments. Now I'll explain why we have these types of assignments and how they are helpful for our students to land and transition into machine learning jobs. Let's take the first type of assignments. The first type of assignments are Python programming assignments. The reason we have these assignments are because in any interview related to data science or machine learning, you will have 1 round of programming interviews. This round basically tests if you can actually program in any major programming language, preferably Python. The reason we focus so much on Python is because it's the most widely used language for data science and machine learning and even deep learning. Now, within the Python programming and SQL assignments, you can break them further down into 3 types. The first type are numerical programming in Python. The second type are string programming in Python. The third type are data-based programming in Python or SQL. First, let's look at the numerical. I'll give you a few examples so that you understand some of these assignments and the reasoning why we have them. So for example, a very simple assignments that we have in the numerical Python programming could be things like given 2 matrices, implement matrix multiplication using for loops. Again, this is a very simple assignment. Again, we have seen these types of problems being asked in interviews actually. Okay, it's a very simple assignment. It tests your understanding of for loops. Again, we have done a lot of live sessions also just on Python programming, explaining how to do numerical programming in Python. Okay, so these types of assignments will help you appreciate the mathematical concepts like matrix multiplication and also build your concepts of basic programming like for loops. Similarly, we have an assignment where we modify random sampling slightly. Again, this falls into the concepts of probability and statistics that we learn in our course videos. So the whole numerical Python programming takes the foundational mathematical concepts like probability and statistics, like linear algebra. These are foundational mathematical concepts that we discuss in our course videos. So it takes these foundational concepts and poses them as programming problems. Again, for each of these assignments, for each of these problems, we give you detailed assignment videos so that you understand the problem well, you understand the logic on how to solve it. Similarly, we have one assignment where we ask our students to write a function that implements log loss. As many of you know, log loss is a very, very foundational loss metric that is used extensively in machine learning and deep learning, right? So this sort of programming helps you learn the foundations of Python programming and apply them to numerical tasks, whether it is random sampling, writing a function to compute log loss, or writing a function to perform matrix multiplication from scratch. Similarly, in lot of NLP, string processing is very, very important. So we have some assignments which are primarily focused on regular expressions only. And we have done live sessions, 2-hour plus live sessions, just focusing on regular expressions in strings only. Similarly, because you have to manipulate data in Python a lot as a machine learning engineer or a data scientist, we have some simple tasks like sorting data, writing SQL queries for specific tasks which are database related. Again, please understand that the Python programming that we discuss in our course videos is not general purpose Python programming. While we cover most of the foundational concepts, we want you to become a good Python programmer for data science and AI and machine learning applications, not a general purpose Python programmer. That's why most of the tasks that we give you are very, very foundational. So most of these assignments are foundational for other assignments and for other concepts that you learn. Everything that you learn in string regex matches, strings and regexes is foundational to a lot of NLP techniques. Lot of data sorting, all of this is foundational to data science tasks. Lot of this numerical programming stuff that you learn is foundational to understanding the core mathematics behind machine learning and deep learning techniques, right? So all of our Python programming assignments are very much tuned to be foundational to other assignments and other concepts that we learn as we progress through the course. Additionally, for students who may not be very strong in programming, we have provided optional assignments. These are not mandatory. These are optional assignments that students can use to improve their programming skills. And if students require more practice, we are willing to give as many problems as they need, right? But we want you to be good at foundational Python programming. Okay. So the second type of assignments that we have is basically where we implement a mathematical concept from deep learning or from machine learning. Let me give you an example. So in one of our assignments, we ask you to implement the cross-validation technique where you do a random search to find the optimal hyperparameters. Okay, it's all in scikit-learn, it's called random search cross-validation. We ask you to implement it. But when we ask you to implement this assignment, we also give you detailed code walkthrough. We also explain, as part of our assignment videos, we explain you detailed code walkthrough of grid search CV, wherein you perform grid search to find good or optimal hyperparameters by doing cross-validation. So we explain a related concept to you. And grid search and random search are two very simple and popular methods for cross-validation based hyperparameter tuning, right? So we explain one technique, we give you the whole code as part of our assignment videos. We explain both random search and grid search in the concept videos, and given all of this and given a lot of external references and starter code for you, we ask you to implement the random search cross-validation, right? So this is one example. Another example here that we just saw is we ask you to implement backpropagation with gradient checking. Again, we spent, as I mentioned earlier, we spent almost 2 hours explaining how backpropagation itself works. We have another almost 1 hour worth of videos for code walkthroughs on how backpropagation itself works. Again, these are part of our course videos, these are part of our assignment videos, and we also give you a lot of starter code. Given all, and in addition to that, a lot of external references. And anywhere you're stuck, we are here to help you, right? So this is another example where you implement backpropagation on a very simple example and you perform gradient checking. Now the reason why we have these types of concept implementation based assignments is because these are very, very popular interview questions. Again, as we have discussed in a lot of our interview questions, a very popular interview question is, okay, can you write the pseudocode for random search cross-validation? Random search based cross-validation. In a typical interview, the interviewer can say, can you write code in Python if you're very comfortable with Python, or at least write pseudocode. And in an interview setup, you're just given 30 to 60 minutes to explain the whole pseudocode, write the whole code. In our assignments, we give you ample amount of time to solve it. You can solve this assignment during the whole validity of your course. We do not give you 30 or 60 minute time limitation the way it would be in an actual interview, right? Again, we have done some interview sessions recently, right? So you might have encountered these interview sessions where we ask, okay, explain how, write the pseudocode for some concept. Again, the reason these questions are very popular in interviews is because these questions help the interviewer assess if you understand a concept deep enough and can you translate this concept into code. Okay, we have seen thousands of interviews where these types of questions are extensively asked, right? So this is also preparing you for interviews, as well as it helps you obtain a deeper conceptual clarity and understanding of a concept like random search or backpropagation, in addition to improving your programming skills, right? So everything that we have in our assignments is geared towards getting you into a machine learning job. The third type of assignments that we have are to solve real world problems using libraries. Again, the libraries, we use multiple libraries starting from scikit-learn, XGBoost, right? Using TensorFlow, Keras. We use a bunch of libraries. We use appropriate libraries for every machine learning technique. Again, the purpose of having these problems or these assignment problems is to give you an experience of the real world work that is done by data scientists and machine learning engineers. So let me give you an example. We have one assignment where we ask you to build a gradient boosted decision tree and perform hyperparameter tuning on a real world data set. That's one example. Another example here is we ask you to design and build a very simple LSTM based architecture, do a little bit of hyperparameter tuning on this on a real world data set which requires sequence modeling, right? Again, this is a type of work that you do. And when you're using GBDT, we ask you to use XGBoost or any other library that you're most comfortable with. Similarly, when you're writing code for LSTM, we ask you to use TensorFlow, Keras, whatever library you're comfortable with. Again, please understand that the computational time required, not the coding time, but the computational time required for some of these assignments can be a few hours. And that's because imagine if you're doing a lot of hyperparameter tuning, you have to train lots of GBDT models. And if you have a large data set, that could take a few hours to do. And that's how things work in the real world. We want you to get an exposure on how the real world of modeling using these libraries and solving real world problems itself works. That's why some of them might have a few hours of computational time. So you have to be a little patient here. Again, the coding time might be very little, but the computational time could be slightly more. And these types of assignments are extremely foundational for the case studies that we have in our course videos, the self case studies that you have. And they provide lot of real world experience on tackling real world problems, solving real world problems using the techniques that you have learned in the course videos, and by performing typical analysis, typical hyperparameter tuning exercises that a real data scientist would actually perform, right? So the fourth type of assignments we have two self case studies, and for these two self case studies, once you solve them, you have to write a detailed blog explaining them. The purpose of these self case studies is to pick a experience relevant problem. So we work very closely with you to pick a problem that is very relevant based on your prior experience, based on your stream of education, whether you are a civil engineer, mechanical engineer, electrical engineer, computer science engineer, in which domain are you working? So we work very closely with you to pick problems which are relevant to your prior experience and background, and our mentors have weekly sync-ups with all of our students who are doing these self-case studies, where the mentors will constantly and regularly guide you on what are the next steps that you have to perform, right, to solve these case studies end to end. Again, we recommend that you come up with a problem of your own based on what you have understood from the course. In case you are not able to figure out a good problem, we work very closely with you to come up with a good problem. And in these self-case studies, we would be building end-to-end solutions for real-world problems, right? So we start from basic data analysis to productionization of these models. Okay, we discuss all of them, and this gives you real-world end-to-end experience that is critical for the industry. And at the end of it, for each of the two case studies that you solve, we also encourage you to write a detailed blog with the code, with your analysis, so that you can showcase your work, and these blogs become your portfolio basically. These case studies and blogs become your portfolio, and they become the way you showcase your skills to recruiters, hiring managers, etc. And we share all of this work with all of our recruiting partners. Now, the infrastructure that you need, the computational infrastructure that you need for completing the assignments are typically any laptop running any of the major operating systems, whether it is Linux, Mac or Windows, with at least 4 GB of RAM. And of course, you can run using Jupyter notebooks or using IPython notebooks. Using IPython notebooks, you can run them locally on your computers and submit them to us. But we also strongly recommend that you use Google Colab, because Google provides free computational resources through their Google Colab, and we have requested many students who have resources which are not even 4 GB RAM on their laptops to use Google Colab, right? Again, people who even have 4 GB or even 8 GB have started using Google Colab extensively, and it has been very helpful for them. Now, having said that, we take plagiarism and cheating very, very seriously. We have built industry grade, truly world-class plagiarism detection techniques that are used both at various universities and at companies to detect if any of our students are submitting their assignments by plagiarizing code from other students or from anywhere on the internet. Please understanding that by participating in plagiarism, you're only cheating yourself, because you're not learning the skills that are needed in the industry. Okay, in the industry, suppose you join a company, if you're found plagiarizing code without informing your legal team, it's not at all tolerated in the industry. If you're found plagiarizing code in the real world, in the industry, you will be thrown out of the company, and no other company would want to hire you. So plagiarism or copying code from anywhere is completely non-tolerated by us. Okay, if you're found cheating or if you're found plagiarizing, we stop evaluating your assignments from then on. And please understand that we constantly update our assignments to minimize and mitigate plagiarism. Also, to ensure that new students are getting new, slightly different problems. The problems are all the same, they're slight modifications of one another. Again, we primarily update our problems constantly to minimize and mitigate plagiarism as much as possible. Okay. Having said that, a very common question that we are asked here are your assignments hard? It's a very good question. So let me break that down one by one. Our assignments are surely not trivial. They are not trivial, because if you have trivial assignments where you just copy code from somewhere, put it, change it 2 parameters and you're done. No. So by doing such sort of assignments, you're not preparing yourself for the industry. They're surely not trivial. Let me make that very, very clear. Our whole team of mentors, guides and instructors have spent thousands of hours designing these assignments very, very carefully. Okay, so they're surely not trivial. Don't expect them to be copy pastes. Number one. Number two, they're fully aligned with what the industry needs. Okay, so many of these assignments have been so designed such that, again, let me give an example. When I say they're fully aligned with industry needs, what does the industry want? Industry wants people who are comfortable with basic programming in Python and SQL, people who have good deep understanding of machine learning concepts and can translate a machine learning concept to code, people who understand the machine learning libraries and can solve real world problems using them, and people who can solve problems end to end. This is what the industry wants. And that's why our assignments are fully aligned with what the industry needs. And they're also based on a lot of interviews that our students and mentors have been part of. Again, lot of our assignment problems are actually small variations of what our students and our mentors have encountered in thousands of interviews that we have been part of, either as interviewees or interviewers. Okay, again, at a wide spectrum of companies, we have people, we have students, mentors, guides from services companies to top product-based companies, right? So we have a wide spectrum of people here, and these people have been part of thousands of interviews, and a lot of our assignments are designed keeping the feedback, keeping the experiences, keeping the needs of the interviews for typical data science and machine learning roles in mind. That's why they are not trivial, because if they were trivial, you would solve them, but you'll never be able to transition to machine learning careers. And to solve our assignments, you need a good understanding of concepts that we discuss in the course videos, the programming that we discuss in the course videos, and the programming assignments that we give at the very beginning. And I'm very happy to see that people and students, especially students who have put in good amount of hard work, there are many students who have completed these assignments successfully. What is needed are three things: good understanding of concepts, good understanding of programming. Again, these two are covered in lots of detail in our course. In addition to that, you need good amount of effort. Again, the effort will differ from student to student. Again, we have a lot of students who are even non-CS students who have done programming probably in their BTech first year. After that, they've never done programming. We have students from mechanical engineering, civil engineering, chemical engineering backgrounds who have completed the assignments and successfully transitioned to machine learning and data science careers. So the three important ingredients are good understanding of concepts, good understanding of programming, and programming assignments that we have in the course videos, and effort, right? So if you do all these three, we do not believe that our course assignments are hard. For a student who is working hard, who is putting the efforts, who is understanding the course videos, who is solving the programming assignments that we have at the very beginning, they can comfortably finish our assignments during the duration of the course itself. Again, anywhere you are stuck with the concepts, we are here to help resolve those doubts. Anywhere you are stuck in programming or in our assignments, we are willing to give you additional material, additional videos, additional live sessions, whatever you need to help you finish these assignments. As I've just mentioned a while ago, we have done, during the lockdown, we have done 25 plus live sessions, which are just code walkthroughs to help our students complete the assignments better. We are willing to do everything from our side as instructors and mentors and the whole team at Applied AI course to help our students complete these assignments. Now the ball is in your court to put in the effort, to complete the videos, understand the concept, to do programming practice, to complete these assignments and successfully transition to machine learning and data science careers.